Welcome everyone to today's online event with MECLA, the Materials and Embodied Carbon Leaders Alliance, as we turn a spotlight onto concrete and cement. As we start today's event, I would like to acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. I'm speaking to you from Gadigal land, and I pay my respect to elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people participating today. My name is Hudson Worsley from Precinct, and I have the great pleasure of being MECLA's chair. I'd like to welcome everyone to this Spotlight event, whether you have dialed in live or whether you are watching a recording. Today happens to be a public holiday in both Victoria and South Australia, and for other people, diaries are busy. So whenever you are watching this, welcome. Concrete is a material that has literally built our modern world and dates as far back as the Romans, for whom it has been described as the building material of choice. Every one of us today, unless you have dialed in from a tent, will have concrete around you. It's vital to our built environment, but the making of cement that is needed to mix the concrete results in significant greenhouse gas emissions, which is why this is a topic of great importance and the focus of our Spotlight event today. Parts of the industry are working hard to innovate and cut the embodied emissions in the manufacturing process. So thank you for dialing in from around the country to join our lineup of speakers as we explore the innovations, the opportunities, and some of the barriers in the journey to decarbonise cement and concrete. MECLA is a do tank, and that means that events like this are all about the discussion, the ideas, the questions, and the sharing of knowledge that then leads to action. Before we press on, as with all MECLA events, I'd like to remind everyone of our governance framework. Our collaboration, now made up of 119 founding partners, comes together to drive reductions in embodied carbon in the building and construction industry. We seek to align with the Paris Agreement targets and principles of the circular economy. But we have to remain vigilant and avoid conflicts of interest and any anti-competitive behaviours. This is just so important to maintain the legitimacy of our collaboration. MECLA is a national alliance, but we are grateful for the seed funding and the support from the New South Wales government that has helped get us up and running. I know that there are many people from different parts of government, different government agencies dialing in today, and we welcome you. You have significant positions that can help shape the demand for low embodied carbon materials, so welcome. A little housekeeping. Please note that we will be recording this event. We are recording it. Usual Zoom rules apply. Please mute yourself when not speaking. Please put your full name on your Zoom label. And questions, please use the chat function. We'll field questions throughout the event as we go. And for Green Building Council Australia members, please note that attending today's event can earn you a CPD point. All right, I'd like to introduce our speakers. Today we will hear from three speakers up front, all with deep industry experience. Margie Thompson is the CEO of the Cement Industry Federation, and she will talk to us about decarbonisation pathways for the cement and concrete sector, opportunities and challenges. She'll be followed by Stephen Foster, Professor and Dean of the Faculty of Engineering at the University of New South Wales, and he'll discuss low carbon concrete technologies, trials and technical specifications. Stephen will be followed by Cindy Lyles, Sustainability Manager at CPB Contractors, and she'll talk about the challenges of demand for low carbon construction. Our speakers will then be followed by a facilitated discussion to be led by Ali Kashani, who is Associate Professor at UNSW and a founding director of Syncrete. Ali is also a very active member of MECLA, and he'll be discussing the transition to performance-based specifications, the challenges and benefits. In addition to our first three speakers, Ali will be joined by Michael Kemp, the CEO of Earth Friendly Concrete at Wagners, Harish Srivastava, Director Civil Engineering at Transport for New South Wales, and Jason Nairn, Director Research and Technology at the Cement, Concrete and Aggregates Australia. So quite a lineup. All right, let's get underway. Margie Thompson, can I please hand over to you?
Well, thank you very much, Hudson. I'll just share my screen. Well, thank you everybody for the opportunity to speak today. I'm going to talk about decarbonising the Australian cement and concrete sector and what are the opportunities and challenges. I'm really the starter to give that overview for those that may not necessarily be highly connected to our sector. So first of all, it's always important, how is actually clinker and cement made, which is the key ingredient of concrete. And I'm always told never to bring a prop, but I have. So here we need to bring our mixing bowls in on stage and start mixing the raw material to make our cement. And it's a bit like making a cake. So you need to put in those key ingredients. So today, instead of our flour, we're going to add some limestone, and then we're going to add some sand and some clay. We're going to mix it together. It will go into a pre-calciner, which is like a smaller oven, which heats it up to 800 degrees. And then, as you can see, there's a big long sausage there, which is the actual cement kiln, which is the oven. Okay, so we're baking our cake. We've put in our limestone, our clay and our sand, and we now need to heat the oven. And instead of turning it up to 180 degrees for our cake, we need to bring it up to 1450 degrees Celsius. This is so hot that the limestone will actually melt into a liquid. And you can see that big long sausage. I always like to relate to things. It's just like a toilet roll. And you'll see at the end of it, there's something which I won't comment on, but that is the actual flame. And the flame needs to be heated using either coal or gas, or, as we'll talk through our presentation today, there are a range of alternative fuels that can also be used to decarbonise our energy usage. So what pops out the end after it's gone through the long sausage, the kiln, is it pops out clinker. And it's clinker which is high in CO2 once you get into embodied carbon, but we'll come into that again later. And from that, you get these little stones of clinker, and they need to then be crushed with gypsum and other products. And you might add some more limestone that hasn't been burnt. And then you end up with the cement that you would go and buy at Bunnings. So next slide. So where are our integrated cement plant locations? So these are plants that actually produce both the clinker and the cement in an integrated process. There's only 5 in Australia. There are over 3,500 in the world. So we have 5, of which 4 are significant in terms of volume. And as you can see, they are always placed either near, they'll always be close to a limestone deposit, seeing that is the key ingredient, or they'll be close to port or near a capital city, which is why you'll see why they are located where they are. Next slide. So Australian production, as you can see, the first one is clinker production, the figure at the top, and you can see that we produce around 5.18 million tonnes of clinker, and that's a very tiny amount compared to the world. Nearly between 60 and 70% of clinker or cement is produced in China. So we're a very small player, but that doesn't mean it's not important for us to decarbonise. And as you can see, clinker imports have grown significantly over time. Our production from our manufacturing sector in Australia has remained virtually unchanged, but as the population grows, so does the demand for our product. And that extra demand has actually been fulfilled through imports instead of putting down further kilns. And as you can see in the bottom graphic, that we rarely saw cement imports, but even cement is being imported in more significant volumes. It's a lot more difficult to ship As you know, if it touches water, it can solidify. And so the majority of clinker trade around the world is actually in terms of clinker. And we have quite a unique profile. Apart from a number of small countries, including New Zealand, you'll rarely see such a large number of imports, clinker imports. It's usually all produced domestically because of the cost. So next slide. So what is the emissions profile of cement? Our total emissions are just under 5 million tonnes. That's just around 1% of our total Australian inventory. We've made significant inroads over the last 20 years. We have actually reduced our total emissions by over 20% over the last 10 years. And as you can see, the emissions intensity factor has actually declined. Next slide. But when you actually put cement into concrete, remember it is the binder that sticks the various aggregates together. Only 12% of the actual concrete is made up of cement. And then you can see that there are what's called SCMs, which are supplementary cementitious materials, which we'll talk to in a moment. And as you can see, there's significant aggregates and then water that are added to the cement to make concrete. Next slide. So as you can see, when we get to the emissions profile for cement and concrete, it doesn't really change that much from when we were looking at cement, apart from there's a further use in terms of electricity and a small amount of transport. And where our profile differs to other building materials is that over 55% of our emissions originate from that burning of the limestone, the calcination of limestone. So when it turns into the liquid, it actually releases CO2. 26%, or about a quarter of our emissions, actually come from heating the kiln, so heating the toilet roll. So when we are looking at heating the kiln, we are really keen to look at how we can decarbonise by using alternative fuels. 12% are indirect emissions related to electricity usage, and about 7% from the transport of cement and concrete. Next slide. And so if you look at the cement and value chain, historically, there's been this real focus on the actual manufacturing facility. But if you look along the value chain, we can see that the opportunity to decarbonise increases as we join hands across that value chain to in our quest to reduce emissions to net zero by 2050. Next slide. I went to a seminar in early 2020. We have always relied on a roadmap by the World Business Council, and there was this fantastic presentation around a whole life perspective, and it demonstrated where embodied carbon comes into play and then whole of life. And from that, we realised that we needed to do a domestic pathways report so that we could look at that full value chain and try to bring all the various partners together in our quest to decarbonise. Next slide. Next slide. Thank you. And so we did this in a hurry. We went looking for some partners to try to ensure that we could inform, one, the second LETS statement, the low emissions technology statement that's released by the federal government on an annual basis, but also to have something, a go-to document, which all across the value chain could then are enabled to be able to go to a single document that would provide an overview of what our emissions profile looks like in Australia, and then also to look at what are the pathways that we need to harness to reduce our emissions by 2050. So this report was done independently. We chose a consultant called VDZ, which is a German affiliate, which also was building a roadmap or a pathways document for the Global Cement and Concrete Association. And from that, I'd like to acknowledge the key sponsors who have put in enormous time as well as money in ensuring that this project actually was released well before its due date, which is only a few months ago, but it seems a long time ago. There's been so much interest in this report. So a special shout out, of course, to our sister organisation, Cement, Concretes and Aggregates Australia, which has played a key role in the development of the report, as well as in its implementation as we develop our engagement plans. And also to the CRCs of Smartcrete and Race for 2030, who provided substantial funding to the project as well. So this is the VDZ Decarbonisation Pathways report on a slide. And there's some really important information that you need to look at in looking at how the build actually happened. I just want to get to my notes. So you can see that on that first part of the slide is the grey bar is business as usual scenario in 2050 if we did nothing. So we had a look at what would our whole value chain look like. And we have done something I don't think any other sector has done in Australia as yet, in that we brought into account our scope 1, our scope 2 and our scope 3 emissions. So we didn't just look at it from scope 1, which is how the safeguard mechanism operates. And if you look from the bottom, we've got our domestic clinker, our imported clinker, and then we looked at how can we estimate our expected market growth between now and 2050. And we found that there's a very high correlation between population growth and consumption. And then if you go further up there, you can see we had to then look at what transport and electricity would look like. And from that, 8 pathways were defined by VDZ to try to capture what are the key elements or key pathways that we can utilise to decarbonise. So on to the next slide. So the first one is zero emissions electricity and transport, which is assumed in the actual modelling. And to do that means that even though electricity and transport is a relatively minor part of our emissions profile, it's a very important one. And so, you know, looking through the usage of green electricity and then looking at how we can green our transport. Transport's really important for this sector. We have some of the largest trucking fleets. We use coastal shipping and international shipping, and we also use rail. And it's really interesting. I'm just seeing the number of EV trucks and agitators, which are the roundy things that take the concrete to the actual site. And they're still in that pilot stage, but they're starting to come on board. So we can see that it is going to happen. It will take time, it will take investment, and that will be the real challenge in moving from the fleets, our traditional fleets, over to those newer EV fleets, or may they be hydrogen based. So next slide. Another important pathway is alternative fuels and green hydrogen. And traditionally at the moment, say 10 years ago, we were using about 10% alternative fuels. Now, alternative fuels may be refined demolition waste, so waste that would have gone to landfill that can be used as an energy source and join that circular economy. Then there are many other products that can be used as waste energy, and that can be anything from tyres to solvents to spent liners from the aluminium sector that can really make a difference. So we have got to the stage where just under 20% alternative fuels at the moment. And we know that in other countries that they have got up to as high as 70%. And we also know that hydrogen is coming on as a potential play as well. At the moment, based on existing technologies, because we need to get up to 1450 degrees, not 800 degrees or 1000 degrees as in other sectors, that it becomes a little bit more challenging for us. So the VDZ report estimates that we'll use around 10%, 10 to 15% of green hydrogen, but that could change. I just read an article last night where they're piloting, so it's just a very small pilot of actually using green electricity to actually heat the kiln. Now, if somebody asked that a year ago, the question would have been that's not possible, or it'd be very difficult to do. So times are changing quickly. There's a lot of R&D out there, and we need to make sure that we're part of it, and that's our real opportunity. Next slide. So new coefficient cements are also really important. And I know that Stephen Foster will speak to this in a lot more detail. So I won't speak to in a lot of detail now, but lower clinker content in cement obviously leads to lower CO2 emissions. And clinker in cement can be replaced by SCMs, such as fly ash, which is a waste product from the power sector, and what we call slag, which is a byproduct from the steel industry. There are many other types of SCMs that can also be used. You can actually use a higher allocation of limestone, and many countries are doing that to lower their clinker content in cement. And there are new composite cements that are also being produced. An example is cements that are based around clay that don't need to be heated to the same extent and don't have the same emissions profile. Alternative binders are also available. And the key challenge, which we see as an opportunity, is making sure that we go through those standards and specifications that are required to support decarbonising cement. So our regulatory environment needs to be staying up to date with what's happening internationally. And we play a key role right across the value chain in making sure that we can trial and use some of these lower carbon cements in our building and construction. Moving over to the next slide, you can also use SCMs in concrete, and we're in a very good position compared to most countries in the world in the amount of SCMs that are actually used at the concrete stage compared to many other countries. But there are also many other things that need to be done as well. And I've put a short list down there, which Jason Nan will be able to answer questions to when he comes on as a presenter later as part of the panel. The reduction in the binder content is really important. Optimizing aggregate grading, improvements in chemical admixtures, the reduction in waste in concrete production. What sometimes if ordering is really poor or not forecasted properly, a lot of product can go to waste. And that's just one of many examples. And again, we need to ensure that we're moving towards performance-based specifications so that we're moving away from looking at ingredients to make a product, but what will create the best type of concrete for that particular build, taking into account the cost, the reliability, and being a decarbonised product in terms of embodied carbon. So next slide. Sorry, next slide. So now we're starting to move further and further away from the manufacturing facility. And that shows us that if we can join hands and really work across the value chain, that we can make a really huge difference in decarbonising the built environment. And concrete being such a core component of most builds plays a core role in what can be done. I can't go into a lot of the detail today because we're not going to have a lot of time, but it's really important to have a look at the VDZ report. Structural optimization, providing the opportunity to use less concrete for the same load-bearing capacity, improving the design assumptions and methods, the age of concrete for strength assessment, improve construction technologies, for example, reducing the need for pumping and shifting from cast on site to precast can reduce binder content. And looking at the building itself, I always love going to Canberra and staying in it's not a historic hotel, it was probably built in the 60s, but it has been extended and so that they haven't pulled it down. So they've been able to really use that building and have the same quality in terms of energy productivity inside the building as you would from a new building. And as you know, with concrete, it has that special attribute in terms of its thermal efficiency, both in terms of cold and in heat. And so it really provides an enormous benefit, not just in terms of the build, but over the lifetime of the actual building itself. What's really important too is when those buildings do come to end of life, or those any type of construction that's based around concrete and other materials, that we try to reuse that material as much as possible and that it doesn't go to landfill and it can be recycled. So next slide, please, Michael. So we're getting down to the pointy end. We're into the last two pathways. This one may shock some people. It's called recarbonation, or as it says in the VDZ report, account for concrete to uptake CO2. Those that are involved in the sector realise that recarbonation has actually been treated as a challenge. It can also be an opportunity. So like a tree, concrete, if it's exposed, actually recarbonates, brings back that CO2. And so those process emissions that were originally released during the manufacturing process can be compensated for. And last year in the IPCC working draft report, they noted for the first time that concrete absorbs CO2 emissions. In the VDZ report, they've put a very conservative estimate of about 20%, but it can be higher. And so we have a project that we are developing with Smartcrete at the moment to look at what methods need to be developed so that we as Australia, along with other countries who are doing the same project, can take that to IPCC. And that would mean that our national inventory for cemented concrete would be reduced under each of those individual country NDCs. And moving on to the last slide, look, is CCUS, so carbon capture, use and storage. We know that it's expensive. It's still early days for the Australian cement and concrete sector, but we have not put it to one side. As a result of the VDZ report, we've been approached by CSIRO, and they are in the process of signing the contract agreement with the HILT CRC to look at a bottoms-up approach from a geographic location of what is actually feasible in Australia in terms of CCS and CCU. We're also very blessed that there are some core technologies that have been produced by Australia, and the potential for those technologies to be trialled at site is something that will happen soon. We need to really look at not just the technologies, we need to look at transport, which can be by pipeline or it may be by shipping. Of course, there's significant capital investment in terms of using pipelines compared to shipping, but shipping is a more expensive option. But we need to look at where we're located, where the kilns are located, and where the sink sites are, or are they close to market that we can actually use the CO2 for other purposes. So it's pretty, it's not something that we expect to happen in the next 10 years, but it is something that is definitely critical unless other technologies can come into play, which is always possible. So going back to the VDZ report, there are recommendations on what are the key innovation areas that should be prioritised. Everybody should go through that list individually. We've got 181 participants I can see down on the screen. It's really worthwhile at this stage to actually put a tick of where your interest lies. And as the engagement plans are being developed with the value chain, CCA will play a key role in this because a lot of this is post the cement manufacturing stage. The opportunity is to bring the various parts of the value chain together to see how we can make a difference. So that's our next steps. VDZ has provided this pathways report. It's only just the beginning. We have made significant inroads to date, and I think that always needs to be recognised, but there's a lot more to be done. We are labelled as a difficult to abate sector, and you can see why when you look at what our process emissions profile looks like, but that doesn't mean we can't decarbonise. It means that significant investment will need to be made, it will be lumpy, and the role of all the various parts of the supply chain or value chain are required, along with government and regulation and specifications along the journey. But we're confident that we will be able to decarbonise by 2050.